As mentioned before, there are a variety of different solutions available on the market for UV disinfection purposes based on UV light sources. We can start from very simple units without optics, just UV lamps, some with reflectors, aluminum-based, standing units or trolleys. Also, there are solutions with more complex optics for upper air disinfections, which you can see in the reality. I don't have it with me now. Anyway, whatever the solution is, we need to characterize it. And by analogy to general lighting, we need to design with the application. We need to design a proper, not illumination, but proper irradiation, let's say. So for that reason, we need to know what is the 3D distribution of radiant power. And to get it, we just need to treat a UV source or UV luminaire as the same way as a lighting source, and use the goniometer to measure and model the 3D distribution of UV. So by installing any of the device on the goniometer, we can rotate it in both directions to see what is the really space distribution of UV of UV light. Sometimes it's quite complex to install the device, which is heavy or huge, but still it allows us to get proper measurements and then design a right disinfection for surface or air. Okay, so mechanically we are almost ready. A UV lamp is installed on the goniometer. So now we just need to make sure it's positioned well. So the optical center of the lamp is in line with the rotating axis. Once we check it, we will be able to rotate the device to measure at different planes and then build up the 3D model. So we can move, say, left and right. In fact, it's possible to go 360 degrees, but with the back side of the luminaire, in this case doesn't make sense because it's mainly radiating on sides and upwards. With the unit installed and positioned on the goniometer, now it's time to set up the right detector and a measuring distance, which will allow us a proper measurement and treatment of a device as a point UV source. For that reason, we set the correct distance of either a radiometer or a spectroradiometer, which of course needs to be sensible in a range of the UVC radiation where we want to measure and characterize the device. So we have either a radiometer, which is calibrated and set for very narrow band of UVC. In this case, it's 254 nanometer mercury line, or the spectroradiometer, which is sensible in the wider range, but covers the UV range completely from 200 nanometers to visual light. Or we can also have a more, say, stationary unit, which is also a spectroradiometer, but clearly dedicated to UV measurements with higher sensitivity in, and resolution in a UVC. The device is positioned on the goniometer. Sensor is set and fixed. We have chosen for spectroradiometer to do the measurements. The position of the spectroradiometer is adjusted and blocked. Now it's time for setting correct parameters in the software. So we approach it in the same way like we would do for general lighting measurements, but instead of luminous intensity, we want to measure radiant intensity in watts per steradian. So based on that measurements, we could after that do the simulation and measurements of the 3D model of radiant intensity distribution. So the distance is set. We have to make sure that the radiometry is the measurement type is the radiometric measurements. The range that we want to register for the spectroradiometric measurements is also set. In this case, we put it at 245 nanometers to 265, which will make sure that we cover the mercury emission line. And yeah, with such a setting, and of course, also for angular resolution, we can adjust, depends on what is needed and how frequently we want to repeat the measurements, every 1 degree, every 5 degrees. This is just an example of the setting. But let's say now we are ready to start the measurements. Of course, there's one more thing. We have to make sure that the stabilization is also, we need to pre-warm the lamp, especially that this is mercury discharge lamp. In this case, it will take some time to get it stabilized, and we also should look at the radiant flux for stabilization parameters. So irradiance will be measured, and once it's stabilized, the measurements will start on its own. We are ready to start the measurement, but before that we need to evacuate from the room, of course. Safety first.